problem. It is kind of an intro to the unit that we're going to be working on because we're going to start a unit on circles. And we did a problem like this before, except for, I think it was like in a hexagon or something like that. Maybe it was like that before. What is kind of the general process if I want to find the area of the shaded region? What do I need to find? Two different things. What do I need to find?
The area of the circle and the area of the triangle.
Good. Got to find the area of the circle and the area of the triangle. And I'm going to subtract them. Which one is going to have a larger area? I heard both. Which one's larger? The circle, right? So we're going to do the area of the circle minus the area of the triangle. Would you agree with that? Okay. So how do I start with the area of the circle? Let's find that. What's the area of the circle? Pi r squared. I agree. And that is a formula that will be on your SOL formula sheet. You have it in your SOL binders that we'll look at probably next class again. What information am I given in the problem? Am I given either pi or the radius? Well, pi is always the same number, isn't it? So the radius, am I given that? What is it? It is 8. Even though it's a radius of the triangle, because it's inscribed inside the circle, it's also the radius of the circle. And so we can leave it in terms of pi, and that's just 64 pi. We good so far? Area of the circle. So I know it's going to be 64 minus something to find our shaded region. Now I just have to find the area of the triangle. Okay. Question? Yeah. Because I'm leaving my answer in terms of pi. If it was a decimal answer, you'd multiply them together. And what is that if I wanted to do that real quick? If I wanted to do that, 64 pi. Oops. Whoa. There we go. I know. It's dark. Oh, goodness gracious. E is a number. All right. Give me a second. I'll tell you. It is 2.7182818828. It's a ratio as well. It has to do with the base of the natural log. That's a number that it's an algebra 2 thing. Don't worry about it, okay? All right, so we have 64 pi. I can't see in the dark. There we go, 64 pi. Yay. All right, 201.06. Either one of those is okay. All right? Now I'm going to find the area of the triangle. What now? How do I do that? Into squares? Yeah, I would have divided it up as well. So if we divide it up into 3 triangles, we'll say, let's use a different color highlighter, maybe to highlight one of these triangles down here. And there's 3 of these. Would you agree? Okay. So we're going to say 3. And then we do have 1/2 base times height. Okay, good enough. What's the base? What's the height? Do I know? I can find it though. Because 8's not either the base or the height. Would you agree? That's the radius. How do I find the base and the height? Somebody besides Julian. I know he knows. Somebody else? Go ahead, Gabriel. Okay, and that gives me what? All right, so and then this angle here would be a 60-degree angle. Would you agree with that? So I do have a 30, 60, 90 triangle, and I'm given the hypotenuse. So I could find the short side, which is always the side we want to find first. Is the short side the height or part of the base? It's the height, and so that's going to be what? 4. Good. So the height is 4, base times height. So now we got to find the base. Well, it's 4 radical 3, and there's 2 of them, so that would be 8 radical 3. Good. We'll multiply all that together. So we have 3 times 1/2 times 8 times 4. And we get 48 radical 3. Is that what you guys got? And so 64 minus 48 radical, 64 pi, isn't it? 64 pi minus 48 radical 3 is the exact answer. And if we wanted to go ahead and give me the decimal approximation, let's see if I can figure out what the pi key is again. 64 pi minus 48 radical 3. And I got about 117.9 if I'm going to round it to the nearest 10th. I'm not sure what units we would have, but if this was centimeters, my units would be centimeters squared for area. Okay. So this is definitely something we have done before. Just a matter of, do you know the area of the circle formula? Sure. We know that's pi r squared. We learned that a long time ago. But we are going to talk a lot about circles. And the first thing we're going to do today is talk about an equation of a circle. So you definitely want to write that down on your notes, is the equation of a circle. This is actually given to us on our formula sheet for the SOL. So it is not something that you're going to need to memorize. And so therefore, if it was on a quiz or a test from between now and the end of the year, I would also give that exact formula to you. Okay? So notice some things. There's an R in the formula. And R is going to stand for radius. The other thing that's unusual, because all equations, a lot of equations have x's and y's in them. So those will probably stay. But the H and the K is something new, okay? And the HK is actually the center of the circle. So this number here and this number here give me the coordinates of the center. And then this number at the end is the length of the radius, okay? We've got our formula written down. So make sure you know what the center is and what the radius is. So I've got a circle here. I've got an equation of a circle. I'll kind of try to put both of those things up there at the same time for a minute. And I want us to look at this equation, and I want us to identify the radius and the center of the circle. I would. If I were you as an example, you need to know how to graph them, how to write equations. So I would write these examples down, yes. Okay, so this is like example 1, so to speak. If you don't want to write it all down, you can always go ahead and print them off at home. All the notes are always complete and put online. So that's up to you. So as you're writing it down, can you identify the radius? What is it? It's not 16. What squared is 16? 4. So 4 is actually the radius. Okay? Notice the equation says r squared. So whatever number squared is 16. Do you know what function on a calculator will do that for you? What number squared is the number we're looking for? What's the opposite or the inverse of a square root of a, I just told you, of a square root. All right, so if I took the square root of 16, you would get the answer, okay? So if you are given an equation, you could take the square root of this last number, and that will give you what the radius is. What's the center? It's not 3, 5. It's not negative 3, 5. Look at the equation. The basic equation has a minus in each of those. So if this is the equation of the circle and the center is HK, then this is, so I agree, 3 is the x coordinate. I agree. But it's 3, negative 5. Okay? Basically, what's inside those parentheses, the sign, in order to figure out what the true center is going to have an opposite sign of what you see. Okay? So it's positive 3, negative 5 is the center of my circle. So if we're asked to graph a circle, you're going to start by doing that, graph the center. So let's go ahead and just kind of quickly do that. You can just sketch it if you want. 3, negative 5. Yes, dear. Why 3 is x? Because it's the number that's in with the x? Yeah, this is h, this is k. H is 3, k is negative 5. That's where those numbers came from. Because the formula has a negative. Another way for you to say it is this y minus negative 5 is the same thing as y plus 5. So that's why it's negative 5. Okay. All great questions, you guys. All right, so I started by graphing the center. And then how do you think I'm going to graph the rest of the circle? Josh, got an idea? You're scratching your head? No clue? Well, I've given the center. How could I use the radius to possibly find some other points on the circle? Sure, if I go up 4, I can do that. So from the center, up 1, 2, 3, 4. What else could I do? To the right, to the left? Crisscross? No. Down? Okay. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And I can just connect them. Hopefully your circle will be prettier than mine. In the equation? That's just what the formula is. That's the format of the equation of a circle. All equations of circles will look like this. That's why I gave you what I highlighted at the very beginning, because that is the given information. That's like the formula. It's like, what's the equation of a line? Y equals mx plus b. You just know what it is. And this is just the equation of a circle. Okay? Okay, so if I gave you the equation, could you tell me the radius and center? Could you graph it? That's like the basic stuff. That's about as easy as it's going to get. It will get harder. Before we get harder, I want to make sure this is okay. If I gave you the graph, could you write the equation? Let's go the other way. Okay? So here's a graph. Let's write the equation. You don't have to copy this one down. But what am I going to need to identify in the graph? The radius and the center. So let's identify both of those first. Okay? Can I do the radius without the center? I can?
No.
Tell me how if you can, because I'd love to know. Pretty sure you got to find the center first, because isn't the radius from the center to any of the points on the outside? All right, so how am I going to find the center?
You found the partisan and the partisan by going left to right.
Finding the diameter? Okay. So kind of finding where maybe this is a point on the graph, this is a point, this is a point. Not exact, but we pretend, kind of looks like that works, doesn't it? And then you would just find the center of those two intersecting lines. I think I probably would do that. I'm just going to draw them in. And so that would happen at this point here. Yes, love. Mm-hmm. I failed that in school. I had a teacher when I was in high school that could draw a perfect circle behind her head. Just by looking at you, just circle, perfect. It was beautiful. I mean, no, can't do that. I don't know how she did it. She was like magic. I called her like the circle fairy. 1, 2, 3, 4. This is the coordinates for 2, right? So that's the center. How do I find the radius? Just count. Sure. Which way should I count? Up, down, left, or right? Doesn't matter. Pick one. You want to go right? Let's go right. So 1, 2, 3, 4, 5. Radius is 5. Do you agree? All right, let's write the equation. What am I going to say? X minus something squared plus y minus something squared equals something squared. So the numbers you're filling in are here, here, and here. X minus 4. 2. 5 squared. Now, if there were a negative and in the center at all, wouldn't these become positives over there? Just make sure you're aware of that, okay? And oftentimes we don't leave it written as 5 squared. Oftentimes we would actually simplify that, and I would like for you to do that as well and write that as 25 there. That's it. You don't have to FOIL or any of that stuff. Okay, that's the equation of the circle. You should not ever do that. I shouldn't say ever. When you get to pre-calculus, you might do that, but nowhere near our level. You will always, for geometry, you will see it written this way always. Okay? Yes, sir. Oh, notice there's always a plus sign in the middle here. Okay, that makes a difference. That makes it a circle. Okay, or an ellipse, but you don't know what that is yet. It's an oval. Okay, and you won't learn about that maybe ever, because it used to be in Algebra 2, they took it out, so I don't know if you'll ever learn it again. Huh? Why they dropped it? They added statistics in. They took it out and put statistics in instead. They changed the curriculum about 4 years ago. All right, so we know the equation of a circle. You'll have some problems in your homework that will deal with equations, and that's pretty much it. We'll look at, well, maybe we'll do one more. Let's write an equation. Well, now, hang on. Let's do this equation. I got a question for you based on this before we get to tangents real quick. So this is a problem we will in a minute. I want you to write an equation, okay? So I want you to write an equation of a circle. So write this down. I'm trying to make it so it's nice. Give me just a minute. Let's do -6. Okay, let's see what that would look like. Okay? I just made this up on the fly, so I'm hoping the numbers are going to work out pretty, but if they don't, we'll still deal with it. How is this problem different than the ones we saw before? I don't see a radius yet or a center yet. All I see is the endpoints of a diameter. So could I find the center and the radius given this information? I sure can. Let's see how to do it though, okay? I would suggest that we start by graphing this. So let me go ahead and pull up a graph real quick, a little sketch just to see, and kind of get a visual of what we're looking at here. And again, if I have to change the numbers, I apologize, but I'm just, since I made it up on the fly here. So let's see. If I'm going to graph the point 1, 4, and I'm going to graph the point 5, -6, there is some kind of circle that passes through those 2 points, and it's the diameter of the circle. Okay? Well, I haven't drawn the circle yet. That's just the diameter. Like, I can go ahead and draw in the diameter if I wanted to connect them. So that's fine if you want to do that. So this is the diameter of a circle. What 2 pieces of information do I need to write an equation? The radius and the center. Okay? How would you suggest, knowing what you know about coordinate geometry, that we find the radius and the center, Julian? Midpoint. Perfect. If this is the diameter, isn't the midpoint of the diameter the center of the circle? Perfect. Remind me how to do that. Does she have a question first? Only if it's a vertical or a horizontal line. If it's not, you can't here. Okay? How do I find the midpoint? What do I add? What do I subtract? Do I take square roots? What do I do? Nope, slope's different. 1 plus 5 divided by 2 and 4 plus -6 divided by 2. Remember, you average the x's and you average the y's. 6 divided by 2 is 3. -2 divided by 2 is, there's my center. Now, Deshay brings up a point. Could I have just counted it? Well, if you found from distance from there to there, you can go halfway down and find it. If you want to do it from a visual standpoint, that's fine. The problem I have with doing it that way is what if it was fractional? What if there were fractions? It wouldn't work that way. Okay? So just be careful. This one didn't have fractions, so it worked out. I made it that way on purpose, but you can, I might not next time. Okay? All right, what else so I have the center as 3, -1. Great. How do I find the radius? Say it louder, Julian. Distance formula. I need to find the distance from the center to the endpoint. I need to find that length. Wouldn't you agree? Okay. So we need to figure that out. So we have the point 3, -1 here, and we have the point 1, 4. Let's find the distance. That will be the radius of my circle. Yep. Absolutely. Yes. Because I've taught it for a gazillion years. So I have 3 minus 1 quantity squared plus How do I do it? -1 minus 4 quantity squared. Okay? So I'm going to have 2 squared plus -5 squared. 4 plus 25, which is square root of 29. Question, Deshay? Oh, just raising, keeping your hand up so it doesn't throb. I didn't ask you to draw it. What I asked you to do was write the equation. I just did the picture to help me see what was going on, really. That was it. So how do I write the equation? Let's go ahead and write the basic form, because you have it. X minus h, I'm going to leave a blank, squared, plus y minus k squared equals r squared. So remember what I told you. When you're writing the equation, I'm filling in those 3 blanks, the h, the k, and the r. So what am I going to plug in? X minus 3, y minus, all right, I'm going to go ahead and change it to a plus, good, and equals the square root of 29 squared, which is just 29. So if you wanted to go ahead and write it, that would be the answer. Okay? Now, go ahead. Well, you would just simply draw a circle that had those as the endpoints, which I'm going to kind of do here. So that's the circle. That doesn't matter, though. I mean, you could figure out approximately, get your ruler out, what is the square root of 29. It looks like it's about 5.4, and you would just estimate. Okay? That's all. Good? All right. So that's really the kind of the extent of the equation of a line, equation of a circle problems. Can you, given an equation, can you graph it? Given an equation, can you find the radius in the center? Given a graph, can you write the equation? And then if I gave you the endpoints of a diameter, could you write the equation and graph it? Sure, no problem. Just know the formula. And again, I'll give you that x minus hk thing. I'll give you that formula there. Okay. So for the last part of class, I just want to kind of talk to you a little bit, and you should already know what these are. But remember how I told you that there's different words that mean different things in math? And tangent's one of those words. We know that tangent is a function. It's like a sine, cosine, tangent. It's a trigonometric function. We've already done that. But right now we also have something called a tangent to a circle, a tangent line. And what makes a tangent line a tangent line? If these are all tangent and over here are not tangent, what makes a line tangent to a circle? Who could explain that to me? Marvin, go ahead. Exactly 1 point. We call that the point of tangency. Okay? So all of these points here are going to be the points of tangency. They don't touch it anywhere else. Notice over here, this point, this line touches it in 2 places. We call that a secant, actually. Okay, when a line goes through it twice, or touches it twice, secant line. We call it over here, when it touches twice, we call this a chord, where the endpoints are actually on the circle. It doesn't pass all the way through. Notice a secant is truly a line with arrows. If we're just going from the center to the endpoint, what do we call that? A radius. We already know what these lines mean. These are just definitions, and do you know what they are? Do you know the difference between a tangent and a secant? And we're going to stick with tangents, okay? No, a tangent is definitely not a chord. A tangent is a line that touches exactly in one place on the circle. On the ones on the left are all tangents. Chords, I'll highlight the chord over here in blue. This is a chord because it's a segment. It has endpoints on the circle, and it touches it twice. Okay? Notice over here, tangent, totally different. Okay? So just make sure you know that vocabulary. What's a tangent? What's a secant, radius, chord? Now, again, I already told you what a secant was. Let's just make sure we can decide really quickly. The first one, it's definitely a secant. How about the second one? Neither. Tangent. Okay, so we know the difference. Would you agree? We know the difference between a secant and a tangent. Good. No. That's just definition, background information. No. If it goes through it has two endpoints. It has two touches it twice. All right, this is just kind of definitions, and we'll come back and talk about these next class, but I want to make sure that I get to the heart of what does it mean to some properties of tangent lines. So we'll come back to more definitions. But basically, if a line is tangent to a circle at a point, so you want to write this part down, okay? If a line is tangent to a circle at a point, remember what the point of tangency is. It's the place that the line touches the circle. So if we have a tangent line, then the tangent line is perpendicular to the radius. Basically, you can just say this. Tangent lines are perpendicular to the radius at the point of tangency. What? A lot of what we can do?
There's another radius.
Oh, a radius?
You can do a lot of radius.
Oh, I know that. Yeah, we're gonna get there at the point of tangency. Just can't get there in the next 10 minutes. That's all. But you're right. Okay. So if I have a tangent line and I have that it is a radius here, we know that it's perpendicular. In other words, we know that to be true. But I highlighted in blue in the picture. They must be 90 degrees. So let's look at a couple of problems that you might see that deal with this exact thing. Okay, let's look at the first one. You don't have to write these down. You can just kind of watch if you'd like. The multiple choice question. I want to find the length of x. Do you see any tangent lines? I do. I'm going to highlight them for you, okay? Highlight them in green. ML is a tangent. It touches the circle in one exact place. What is the point of tangency? L. Good. I also see that MN is a tangent line. Or it's a segment, I get it. That's not a true line. What's the point of tangency? N. So what do I know about some angles? According to what we just wrote. Some angles are 90 degrees. Can you identify which ones are? Okay, so we should. Don't you agree that this angle is 90? It's a radius and a tangent. Remember, if that's true, it's 90 degrees. Same thing with angle ONM. Isn't that also 90 degrees? Because I have a tangent line and a radius. How can I find the measure of angle x? Nope. Think about it. I want everyone to look at that picture. Everyone to kind of come up with it. Don't assume 180 is involved. It's not. Josh, you want to help us out? How do you know that? Perfect. I'm going to highlight the entire thing now in blue and green. This in and of itself is a quadrilateral. And we just finished our unit on polygons. We know that the sum of the interior angles of a quadrilateral have to add up to be what? 360. So right now I have 90, 117, 90 plus x should equal 360. Yes, you could do that too. As long as you knew why. Okay? I agree. All right, so what do you get when you do that? 63? That will make it all add up. Okay? So be careful. Look for tangent lines, look for radii. Yes? The problem is that you don't know that 117 would be divided in half. And it wouldn't be necessarily, so be careful, okay? Because in this case, it actually wouldn't be. So that sometimes that would work, but not in this case, okay? All right, how about this last problem before probably can get through 2 more, I think. How do I find this value of x? So again, I want you to identify, do you see any tangent lines? Let's draw one in. Tell me what line's a tangent line. DE, I agree. Do you see any radii? Yeah. Yes. DO, OD. I can kind of extend that to the whole thing. Is that okay with you? It's still it's a diameter, but it's still perpendicular to that. Wouldn't you agree? So we'll just draw that in. We know it's perpendicular because we just learned that. Tangent lines are perpendicular to radii, or diameters. How do I find x? Now we're in a triangle is a shape we're dealing with. Before it was a quadrilateral, and they should all add to be right. So I know that 38 plus 90 plus x is equal to 180. So what's x? 52 degrees. Good. Okay. So these are some of the things you'll be able to see on your homework is can you identify the missing angle based on what you see here. Okay? Last one that I want to look at. This one's a little bit harder. And I don't think we're going to be able to get through it. But I want you to look at it, and let's think about at least what you think we would do to start it. I want to find the length of the radius. Well, all x's are the same. Nope. Don't care about the angles, actually. Good thought. I mean, I couldn't even find them yet. What? We only are dealing with sides right now. Would you agree? Think about right triangles, back when we did right triangles. When we only dealt with sides, what kind of thing did we use? The Pythagorean theorem. That's right. So we're going to use the Pythagorean theorem here. I agree. But let me set the Pythagorean theorem up, and then we'll finish it next class. Tell me what I'm going to write. 12 squared plus x squared is equal to 8 plus x quantity squared. And that's harder because that is not 64 plus x squared. If you remember from Algebra 1, you have to write that twice and multiply it out using FOIL. Okay, so it's going to take a little bit more algebra to deal with, and we'll finish it up next class, okay? So let me go ahead and give you your homework, and I need to explain your homework because it does require a regular textbook, or you can get a copy of because it won't work on the online book, okay? So in your regular textbook, there is a section between, guys, please just wait for me. There is a section in your book between chapters 10 and 11, okay? And it is called the Virginia Lessons and Standards Review. It's got these purple edges to it. Do you see that in your book? You're going to do lessons 12 and 13. So I'm going to, the page numbers are literally VA 12, VA 13. 12 is just the work, kind of like the lesson. 13 is the actual problems. It's all equations of circles. That's the only place in the book where it is. So if you want to come take a picture of this page, if you have it on your phone, that's fine. I'll leave it here for you. There's also another page you'll need to do, but VA 13 is there. So your homework is going, oops, hang on, I think I have it right here. No, here's the, Pearson's just a general for the whole country. This book is specific for Virginia. So if anybody who can't take a picture of VA 13 and needs me to print it off for them, stop by tomorrow morning and I'll get one printed for you, okay? How many of you think you will need that so I know? How many do I need to print? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll make a few, okay?